Welcome back to AI on AI, the show where we break down cutting-edge research so both CTOs and CEOs walk away with an aha moment. Today, we're dissecting sequential diagnosis with language models and the MAI diagnostic orchestrator.
Thrilled to be here. Let's set the stage. Sequential diagnosis is basically Sherlock Holmes in a lab coat, asking the right question in the right order at the right cost.
Exactly, and the benchmark they built, SD Bench, flips the usual static quiz setup into an interactive detective story. Each turn you pay in dollars and in model tokens, so efficiency matters as much as accuracy.
And under the hood, the real star is orchestration, not just a beefy model, but a committee of specialized agents. Hypothesis tracker, test chooser, challenger, stewardship, and checklist, all rolled into prompt engineering.
From a clinical lens, that's what we actually do during morning rounds. Our Gyrus once said, "Learning occurs when we detect and correct error, and this multi-agent loop forces the model to detect its own anchoring errors."
Let me jump in from the business angle. If an AI can drive 80+% diagnostic accuracy at 20% lower cost, that's straight to the bottom line for payers and provider systems, and it opens cross-border telehealth markets.
Love the 30-second summaries. Now let's unpack the technical mechanics. How does the gatekeeper keep info leakage in check?
Well, think rule-based wrapper plus retrieval-augmented generation. The gatekeeper has full case access but only releases findings when explicitly queried, refusing vague prompts. That's enforced via a deterministic policy sitting on top of a slim O4 mini model.
They trained a refusal classifier that fires on semantic fuzziness. So tell me everything gets blocked, but order a CT chest with contrast passes. Critical, because if the gatekeeper blurts out pathognomonic clues early, the task collapses into trivial.
And to avoid the negative Q not available, they synthesize plausible lab values. That's subtle. Missing data can act like a neon arrow. By filling in realistic synthetic results, they keep the reasoning space natural.
Clinically, that mimics reality. We often order tests and get normal back, which is still informative.
For CFOs, synthetic data also sidesteps PHI issues during development. Huge compliance win.
All right, flip side. The cost model, $300 per physician visit plus CPT-based test lookup. How solid is that?
It's a proxy, obviously, but they used real price transparency tables under CMS rules. The bigger point is relative comparison. Pareto curves tell you which agent dominates regardless of absolute dollars.
And that's why MyIDXO shines. With the same underlying model, orchestrated runs land left and up on the frontier. Better accuracy, lower cost. In Monte Carlo analysis, that dominated 97% of random baselines.
Quick analogy, think airline route planners. Same jet engine but optimized routing, shaves fuel. MyIDXO is the flight management system.
Speaking of MyIDXO, can we double-click on the Bayesian updating the hypothesis doctor does?
Sure, each differential item holds a prior probability. When a new finding arrives, they compute likelihood ratios using pre-stored tables derived from big HR datasets and update via P equals P old Z. They only keep the top 3 hypotheses to stay within context window.
And to pick tests, Test Chooser approximates information gain per dollar. IG equals H of SES, P up to outcome, divided by cost. It's greedy, but empirically good enough. Funny thing, humans rarely do that math explicitly. We use heuristics. The model finally codifies what evidence-based medicine textbooks preached for decades.
And stewardship agent audits that, if IG dollar falls below a threshold, say 0.001 nats per dollar, it vetoes.
Which translates to payer language, medical necessity. That reduces denial rates downstream, slashing administrative waste. 60% of appeals in one pilot ended instantly because the AI rationale matched insurer policy.
That's a concrete business win. Let's toss another. How does this tech fit retail clinics or pharmacy chains?
Think of minute clinic-style setups in big-box retailers, staffed by one nurse practitioner. Plug MyIDXO as a second set of eyes. Early simulations show 30% fewer unnecessary urgent care referrals. That keeps customers in store and lifts front-of-store sales.
Another vertical, occupational health. A Fortune 100 logistics firm used a strict question-only mode to triage back-to-work cases, saved them $1.2 million in lost time wages in a quarter.
But hold on, scaling isn't trivial. EMR integration, local formularies, regional disease prevalence. The model saw NEJM cases, not routine sinusitis. True, and distribution shift is real. We'd need fine-tuned priors using local epidemiology. A heat map prior of disease prevalence by zip could recalibrate hypothesis agent.
Plus calibrating uncertainty, they currently use Judge Score WISE 4 as correct. In production, you'd need well-calibrated probability of correctness to trigger human override. Deep ensembles or temperature scaling, pick your poison.
All models are wrong, but some are useful, George Box reminds us. Calibration turns wrong into useful.
Great, now an unexpected angle. Are we over-indexing on cost reduction?
I'll bite yes. Focusing narrowly on dollars risks penny-wise, pound-foolish outcomes. A cheap but late diagnosis of sepsis explodes ICU spend. The real KPI is value-adjusted life years.
Plus patient experience. Nobody wants 20 separate blood draws to save $20 on a CT. That's why the stewardship agent could evolve into a multi-objective optimizer. Cost, invasiveness, turnaround, patient-reported comfort. Think Pareto in 4D, not 2D.
Mathematically, that's vector-valued reward. You can do scalarization with dynamic weights based on context, e.g., higher weight on speed in suspected stroke.
Switching gears, model agnosticism. They ran it on GPT-4o, Claude, Gemini, Grok, DeepSeek, Llama. What does that mean for vendor strategy?
It's hedge insurance. Hospitals fear vendor lock-in and regulatory risk if a single model drifts. An orchestrator layer lets you hot swap models like database engines, BIOLM.
Technically, the key is instruction invariance. They chunk panel prompts into stable JSON payloads so token order differences across models don't break logic.
And they set a compatibility suite. 170 unit tests of expected reflexes, refuse vague requests, prioritize high LR tests, etc. Any new model must pass before deployment. That's akin to board certification for AIs. Love it.
Let's talk limitations. NEJM cases are zebra territory, no healthy patient. How do we gauge false positives?
They need a prevalence-weighted benchmark. We could simulate synthetic chief complaints drawn from CDC outpatient stats, then embed NEJM zebras at 1% frequency. That'll test restraint.
And add temporal budget. Every question costs 5 minutes of clinician time. MRI costs 4 hours of patient time. Makes the scheduling queue another constraint.
I foresee reinforcement learning with resource constraints, maximize utility under cost-time-risk budgets.
For health system CFOs, that becomes a digital twin. Run scenarios, see the effect on throughput, margins, patient outcomes.
Before we wrap, quickfire. One prediction each for next 24 months.
Multimodal integration. Pathology slides and radiology images piped straight into the panel via vision encoders, boosting accuracy another 5 points.
Auto-extracted likelihood tables from large EHRs using causal inference, so the Bayesian updates get personalized priors by age, comorbidity, and location.
Federated orchestration. Edge-deployed gatekeepers in hospitals to protect data. Cloud-based reasoning panels, fully HIPAA compliant.
Continuous learning loops. Clinician feedback fine-tunes the challenger persona, curbing overconfidence.
New reimbursement codes for AI-augmented diagnosis. CMS will pilot a value-based model that shares savings between providers and payers when AI drives down net cost of care.
Final takeaways. The technology marries reasoning discipline with cost mindfulness, but deployment success hinges on calibration, local data, and multi-objective metrics. Strategy without tactics is the slowest route to victory. Tactics without strategy is the noise before defeat. Sun Tzu's line fits perfectly here. Thanks to all our experts, and thanks to you for tuning in. Until next time, keep questioning intelligently. Welcome back to part 2, folks. Time to roll up our sleeves and peek under the hood of MAI DXO. Let's translate white paper diagrams into the nuts and bolts that CIOs and chief medical officers actually need.
Right. So first stop, the gatekeeper service. Think of it as a zero-trust API in front of the patient record, where every query is a structured request object with scopes like history, lab, or imaging, and the policy engine decides allow or deny.
And that policy engine isn't hard-coded. It's a hybrid stack, a rules layer written in plain YAML for deterministic constraints, no interpretations, no future tests, and then a small language model fine-tuned to classify intent granularity, which cuts false refusals by about 18% versus rules alone.
Exactly. And to prevent prompt injection, say a model tries ignore the rules, the request object gets sanitized through a static analyzer that strips meta instructions. If anything malicious slips through, a checksum mismatch triggers a hard refuse.
There's also latency to think about. Each gatekeeper call adds roughly 400 milliseconds at the edge. So in production, we'd batch 5 question tokens into one request and compress JSON responses, shaving 120 milliseconds on average. Tiny, but over thousands of daily consults, that's real clinic time.
And shorter consults translate to capacity. One urgent care network modeled this and found a 5-minute reduction per visit could generate an extra $2.1 million in annual throughput without hiring additional staff.
Nice bridge. Now deep dive number 2, the Bayesian hypothesis engine. How are they actually storing priors and LRs?
They started with UMLS concept IDs and plugged in conditional probabilities mined from a 12 million record EHR slice using weak supervision. Every finding disease pair gets a beta ava beta posterior, which the panel flattens into log odds tables, so the update is just addition. O new equals O old plus log LR.
Building on that, they cache the top 3,000 LR entries per disease in Redis. That way every update is sub-millisecond, making it feasible to run iterative loops even on constrained hardware.
What I love is the probability leakage guard. When total probability drifts above 1 due to rounding, stewardship renormalizes with a softmax divider, a small but crucial step. We saw earlier prototypes hallucinate because sums crept to 1.05.
One contrarian note, those priors are U.S. hospital weighted. Deploy this in rural India and dengue overtakes Lyme in prevalence overnight. You need a regional prior service, else you get systematic bias.
From a payer's perspective, that regional layer is a strategic moat. Whoever owns the epidemiology as a service API becomes indispensable to every LLM vendor touching healthcare.
Love the strategy angle. Third technical slab, the cost estimator pipeline. How is free text order a CT angiogram mapped to dollars?
They trained a sentence BERT embedder on 8,000 radiology orders paired with CPT codes. At runtime, a KNN lookup returns top 3 codes with confidence scores. Then a deterministic resolver picks the cheapest equivalent procedure. That's where stewardship can still override.
And to cover the 2% long tail where mapping fails, they fall back to GPT-4o with a chain of thought prompt like return code description confidence. Unit tests ensure hallucinated codes don't pass. If confidence 0.7, they mark cost as median of class, so the simulation keeps flowing.
The beauty is that this same mapping logic doubles as an audit tool. Hospitals can spot discrepancies between physician order text and billed CPT codes, which the OIG finds at painful levels.
We're piloting that audit overlay in a Midwest health system right now. Early runs flagged $600 K of upcoding in just 2 weeks. ROI narrative writes itself.
Speaking of pilots, can we paint a concrete end-to-end architecture for tech leaders?
Sure, start with a VPC-hosted gateway exposing/diagnose. Incoming JSON carries the chief complaint. Orchestrator sitting on a GPU-like cluster spawns the 5 virtual doctors, each just a chat completion with role-specific system prompts. They share a Redis pub sub for state, and a Postgres ledger stores every question, response, and cost for auditability. We also wrap the whole loop in an execution timeout, say 45 seconds total, to guarantee a responsive UX. Any unfinished reasoning triggers a fallback recommend specialist referral, which is safe by design.
Security tip. Isolate the gatekeeper in its own subnet with read-only access to the EHR Firestore and rotate its service token hourly. That limits blast radius if a model slips PHI into prompts.
Add feature flags. If a new model version rolls out, canary 5% of traffic. Monitor judge score deltas in real time. If accuracy dips, automatic rollback. You don't want a midnight pager after a bad fine-tune.
Switching to business levers, what revenue models are emerging?
3 patterns: SaaS license per consult seat, outcome-based shared savings, and enterprise flat fee with usage tiers. Payers prefer shared savings. For example, if diagnostic cost per COPD case drops 25%, AI vendor gets 30% of that delta.
Providers lean toward flat fee, predictable budgeting. They'll pay an extra 10% for bundled malpractice coverage, which some insurers are already underwriting.
And pharma. They're exploring DXO for adverse event triage in trials. Early detection of rare toxicities during Phase 2 can shave months off timelines. A single month saved is tens of millions.
Let's not forget global health. NGOs running TB programs can use a question-only version over SMS. Cost per triage under 15 cents, beating call center nurses by an order of magnitude.
Now, earlier we touched on multi-objective optimization. Any concrete algorithmic path?
One approach is Pareto Q-learning in a discrete action space. Each test has a reward vector: accuracy gain, cost, invasiveness, time. The panel agent updates a frontier rather than scalar Q values, then uses knee point selection based on clinician-defined weights.
We prototyped that with synthetic cases. Convergence took about 1,000 episodes versus 200 for scalar RL, but once trained, policy queries were as fast.
But you still need interpretability. A nurse practitioner must see why the agent chose a nasopharyngeal swab over a CT, so we generate a one-sentence rationalization pulled from the hypothesis log. Swab rules out RSV at $5 versus CT at $400.
That explanation doubles as audit evidence for value-based care contracts. Remember, payers scrutinize any AI-driven variants.
Let's tackle deployment hurdles: regulation, liability, and clinician buy-in.
On regulation, FDA's proposed framework treats this as decision support software. If the rationale is inspectable and clinicians remain the final decision makers, it may stay in enforcement discretion for a while. Less red tape.
Malpractice, though, is murkier. Insurers currently extend coverage if the AI tool is on the hospital's approved device list and logs prove adherence to guidelines. Documentation is everything.
For adoption, we found the pilot champion heuristic indispensable. Identify one physician who loves new tech. Let them evangelize internally. 80-20 rule. Win over 20% of clinicians, and the rest follow.
And surprise insight, the interns are more resistant than attendings because they fear being replaced. So frame it as a learning accelerant, not a competitor.
That's a twist I didn't expect. All right, final rapid fire. What tooling gaps still need filling?
A publicly available library of LR tables, open-sourced and peer-reviewed.
A benchmark for benign finding suppression to test false positive restraint.
A UI kit that overlays explanations on EHR dashboards. No tab switching.
Patient-facing summaries at 6th grade reading level. Build trust.
And a revenue recognition API, so CFOs can reconcile AI savings with financial statements automatically.
Music to every stakeholder's ears. To close, remember Drucker's line: plans are only good intentions unless they immediately degenerate into hard work. The paper gives us the plan. Now it's time for the hard work of implementation. Thanks again to all our experts, and thanks to you listeners. See you on the next AI on AI deep dive. All right, let's land this plane. Rapid round reflections. One big takeaway each, then I'll stitch a closing recap.
For me, it's the orchestration pattern. 5 lightweight personas plus a Bayesian backbone. That's the recipe that turned a raw LLM into a disciplined diagnostician.
Same theme, but zooming in. The beta binomial priors and log odds updates showed we can graft classical statistics onto generative models and get the best of both worlds: interpretability plus creative reasoning.
I'd add the cost estimator pipeline. Mapping free text orders to CPT codes with hybrid retrieval and LLM fallback is quietly revolutionary. Opens doors to real-time financial governance. not just clinical guidance.
Strategically, it's the regional prior service. Whoever controls those prevalence tables effectively owns the context layer and by extension dominates local markets.
And from the CFO's chair, the shared savings contracts create an automatic monetization path. You align revenue with measurable cost avoidance, which is music to every boardroom.
Love the brevity. Now, building on those, what's the single biggest risk we still haven't cracked?
Data drift. If hospital workflows change, the priors and cost tables get stale faster than anyone expects. Continuous calibration pipelines are non-negotiable.
Plus evaluation gaps. SD-Bench is fantastic for hard cases, but we need everyday sinusitis and sprained ankles to gauge overdiagnosis risk.
And we haven't fully tackled multimodal. Imaging, auscultation audio, even patient-captured photos all will stress the gatekeeper design.
From a policy view, the black swan liability scenario, AI suggests a test, clinician ignores it, outcome is bad, courts will test the documentation rigor.
Last one, deployment equity. If only top-tier hospitals can afford the ensemble mode, the digital divide widens. Cloud subsidies and open-source baselines could mitigate that.
Great points. Final lightning, one forward-looking prediction.
In 2 years, dynamic role orchestration will be auto-tuned per patient profile, geriatric versus pediatric panels, for instance.
I see Pareto Q learning moving from research to production, balancing 4 or 5 objectives seamlessly.
Cost estimator tech will spill into revenue cycle management and slash administrative overhead by double digits.
Regulators will mandate transparent hypothesis logs, making explainability not optional, but legally required.
And insurers will start offering premium discounts to practices that adopt validated AI diagnosis pathways, similar to telematics in auto insurance.
All right, let me weave a bow around today's journey. We unpacked MyDxO's architecture, from the zero-trust gatekeeper and Bayesian differential tables to the cost-aware test selector, illustrating how structured orchestration transforms a clever language model into a superhuman yet budget-conscious diagnostician. We explored concrete business plays, shared savings, audit overlays, global SMS triage, and flagged critical risks, from data drift to equity gaps. Bottom line, sequential diagnosis isn't just an academic benchmark. It's a strategic lever that can bend the cost-quality curve, a true triple-aim enabler. As Peter Drucker reminded us, plans mean little without execution. So your homework, listeners, map one workflow where orchestrated reasoning could shave time or dollars, run a sandbox pilot, and let data, not hype, guide your next move. Thanks for staying with us on AI, and until next time, keep experimenting, keep measuring, and keep pushing the frontier.